Problem number 146, LRU Cache. Design a data structure that follows the constraints of a least recently used LRU cache. Implement the LRU Cache class. The class initialize the LRU cache with positive size capacity. And get function return the value of the key if the key exists. Otherwise, return -1. Put function update the value of the key if the key exists. Otherwise, add the key value pair to the cache. If the number of keys exceeds the capacity from this operation, evict the least recently used key. The function get and put must each run in a 1 average time complexity. Okay, so for initialization, we will definitely have a capacity property. So to manage the size of this cache, so when put, we should check check if key exists. I think if it's key value pair, then we will have a dictionary. So yeah, we will have, let's call it okay, so the things that we need to memorize are and we need to keep track of the keys and the key value pairs that we have. And also we need to keep track the least recently used key value pair. It's like sorting, so I'm thinking of sorting, like maybe an array, like a stack thing, or a heap. Okay, so if using stack, then every operation, like whenever we update the data or we get data, it needs, if the data is at the bottom of the stack, then we need to move it to the front, to the top of the stack. Then it needs and time complexity. And for heap, it will need every time we add, it would need a big O log n time complexity. So heap will be faster. Like if we use heap, then we can have the we can calculate the age of the key. Then if it is it is called by get or called by put, then we can add 1. And we will maintain the least recently used key in the top. So it will be min heap. Okay, so like min heap, the stack will have O and time complexity. This will have O log n time complexity. Okay, and we still need a map, a dictionary to keep track of the key value pairs. So this will be dictionary, and this will use min heap. Okay, so we'll have map equals dictionary, and we will have a heap. It will be the structure will be every node will be age and thinking, okay, age or because it will be frequency. Every time if a key is get by someone, then we should move it to age and frequency is different. Like if one element, it is one key, if we add 1 every time, add the age by 1 every time the element is being get, then if one element it is saying it only get by 1 time, but it is the most recently get, so it cannot be deleted. Then I'm thinking of what should we put for sorting every node. Maybe the timestamp. Like the timestamp maybe is a good idea. Like then we can use every time a node is getting called, we can update its value to this heap value to current timestamp, so that the smallest timestamp will be popped out when the space is not enough. Yeah, okay. Then we will use timestamp. Okay, so get if key in map. Okay, if key not in map. If key not in map, then return -1. If key in map, then return the value. We need to update the timestamp. Okay, so then finding node is not easy. Okay, so finding it will use on time. Yeah, let's find it. So find it by key and I'm thinking of if there is a way. No, but yeah, like we cannot control the heap, the sequence, the order of the heap. Wait, so if we every time updating timestamp will be and then let's see put. Yeah, we will check if key exists. Okay, if not exist, then we will add. Okay, if exist, update the value of the key. Okay, so if key Okay, so first of all, check if key exists. Yes, then we will update the value in map, and also update the timestamp. If no, then check if capacity is enough. Yes, then add key to map, and also add current timestamp in heap. And no, if capacity is not enough, then pop the least timestamp key and add new value. Okay, so like this, this will take all. Okay, so update the value. This will take big O n, and this will take O log n. If we use stack, then now this will be still O n. Yeah, because we need to find and where we hit and map. Then if stack if you use stack, then this will be O n. At current, it will be O1, since if we don't sort every time, then before we pop, we can sort. Then it will be O n log n. Yeah, it's a trade-off. Okay, so yeah, we can. Okay, let's first update. Yeah, find the node with key, and yeah, let's update the timestamp of heap. So like x is 1 equal key. Then node 0 will be current timestamp. It will be now like this. Yeah, I'm not sure how to. Oh, this will be OM plus log n. Yeah, maybe stack will be better. Like stack, then we'll just we'll find and then update. Then nothing happened. Okay, then we will use stack. Add current timestamp and stack, then it will be O1. Then pop the list timestamp key and add new. It will be O and log n. Since we will sort, then yeah. So if key and this is self map. Key and map let's update the value of the key. Else if capacity, we need total capacity and current used, like current used capacity okay. Else if self use capacity is smaller than self capacity, total capacity, then we can add. Yeah, so we will let's have else, so we can add add value to the map. So self map key will be value. No, we should, yeah, I think it is better to, do this, then we can add the key to the map, and then we will add the timestamp will be now and key. We'll store it, and then we will reverse. Yeah, so the largest timestamp will be at index 1, then we will pop the least used key, and then we will also remove self map. Yeah. Removing key, and yeah, this is the timestamp, and it's the removing key, and then we will this we need to also add. Yeah, we need to find the key node and update the timestamp to now. This will be removing, and then we will have to update 2 keys. One will be delete, self map, delete, removing key, self map. We will add the new key, so it will be key and value, and we will add it to the stack, so it will be like this. Okay, I need to check whether find is writing like this, and also the timestamps, and delete. Okay. Int. Oh, there's in milliseconds. Yeah, we can have this. So this time, now will be this. And then it's find, Python find object in list find tuple in list. You can do it like this. So it's like yeah, you will have index oh no, because we don't know the timestamp, so we need to do yeah, maybe we can do a for loop thing. So for time and key in self stack, if key equals k, let's have k equals key, then we'll update that's I think we'll have that node, then if node 1 equals key, then we'll set its timestamp to time. Yeah, this will be big O-N, and then start. I think we need like a finding. Okay, only this needs as well. So for yeah, for node in self stack, if node 1 equals key, then that's update its timestamp. Then oh yeah, we need to add self, yeah, its capacity should be added by 1. Timestamp and then key. And yeah, we need to sort. and then pop the list timestamp. And Python dictionary delete. Python dictionary delete. Okay, so you can use pop. We'll use pop. And what is this none? Okay. Oh, we can also use delete since we don't need a value. Yeah, we don't need it. This will be added and yeah, we don't need to add modify the capacity because it's removing and adding. So yeah. Okay. Yeah, we can try run. Like okay, for example, this one we will have cache capacity 2. Then 0, okay. And then put 1 1. So 1 is not in a self map. Okay. And let's see if there is any mistakes. Stack thing has self. Okay. So put key 1 and value 1. So self use capacity is 0, self capacity is 2, so it's smaller, and that's add map. Yeah, map will have 1 1. And then stack append current time and key. So we will have let's have current time is now 1 and key is 1. And then use capacity plus 1. So 1 of 0, I have 1. And then 2 2. So now it's 1. Capacity is still smaller, so we will run this condition, run this clause, and self map key. Okay, add 2 2 inside. And append 2 with current time 2. And then capacity added by 1, so 2. Okay, then get 1. Get 1. Okay. Then 1 key is in self map. So we will have this for loop. Update the timestamp for the node in stack if update, then we can break. Yeah, so if node 1 it's key 1, okay, then update this time to 3. Then we will return 1. Okay, then put 3. Okay, since capacity is now full, so we'll run this clause. We will sort our stack, so it's going to be in a reverse way. Okay, so it's now current sorted stack. Then we will remove 1. Remove the pop, and we will get its removing key, which is 2. So 2, we will pop the map with key 2, and the new key will be added. So new key is 3 with 3 value with 3, and we will append the new value to 4, and it's key 3. Okay, and then get 2 now. Okay, so since get 2 is in the self map now, so we'll return -1. And then we will have 4. Put, since capacity is full, so we will sort again. Sort. Then we will pop this, and we will have removing 1. And we will add the new key inside the map, which is 4. Then add to the stack. It will be 5, 4. And then get 1. Okay, it's not in the map, so return -1. And get 3 will return 3. But we will update the timestamp, so it will be 6. Let's say 7. And we'll return. We will get 4. We will return 4 and update. This will be 8. I think we have correct answer. And run. We need like time. Okay, I forgot that tuple in the list cannot be multiplied, so we should use an array. So it would be like, it should be like this. Like array and array. Try. Oh, then so we need to, yeah, I think maybe it's like x0 oh, sort with timestamp. Yeah, we need reverse Python list sort descending. Oh, like reverse true. Let's try if this works. Okay, so then let's submit. Okay. So it's too slow. Okay, so I have checked the solution and I found that the problem requires get and put with time complexity of 1. So this using this data structure definitely not work. Yeah, because stack will use on and inhib will use on. Okay, so then we should change our data structure and the solution said it's better to use a map and also a linked list, double linked list. So it will be let's clear this. Yeah, this will be dict and it will be key to node, and this will be doubling linked list. Okay, so map will be key with node, and linked list will we will have we will have a dummy node that is head and also a tail dummy node. Oh, we first should have a list node class. Init function self, and we need the value next and previous since it is a double linked list. So self value equals value and default to 0, default to none, default to none. So next is next. Okay. Okay. And self prev is prev. Okay, then let's start. Yeah, we should have the head and tail node, so that when we need to have head node, dummy head node, so that every time a value is read or write, we should move it to the front. So we should know the head position and insert the node to the front before the head. And also and then we also need the tail, so that when the capacity is full, then we should remove the tail node. So but we will use a dummy node so that it will be easier to locate the node. Okay, so self head will be empty node, and tail will be an empty node as well. Okay, let's say key to node. Okay, if key is not in the map, then return -1. And then we should it's the node, key to node, key and value access is value and return. And then we should update the it's order, the linked list node order. First of all, for the next node of head, it is tail node. And for tails prev, it's head. Okay, then let's update. So we need to remove the node. Okay, first get the position, get the reference of node, remove it from list, and add it to head. So we will get it from the node, we will get it from the map. So it will be self key to node, get it was key, and okay, so we will have the nodes previous node. So prev node equals node prev, and its next node. Next node equals node next. And we should assign prev node next to next node. And then this is remove, and we will add it to head. So self we first will save the next node of head. I think we can do it like node next is self next. Yeah, and then self head next is node. Okay, then let's do put. So yeah, we'll first check if the key exists. Okay, if key in key to node, then we will update the value in map. Wait, yeah, let's rewrite this. Okay, if key exists in the map, in key to node in map, then yeah, we will update the value and move the node to head. If no, then yeah, we will check if capacity is full, then we will remove the last node in list and add new one to head. And if it's not full, then we will just add the new node to head. Okay, so if key in key to node map, we will its value will be updated to value, and then and we will move the node to head. So we will get the node first. Node will be updated, and then we will remove it from this and add it to head, same as here. I think maybe we can write a function like move to head, self, and we will input node, and this will be list node. So we'll copy this and we'll return none. So prev node will be node previous, next node will be nodes next, and we'll start previous nodes next to next node. Then node next will be the head, and head next will be assigned to node. Okay, then we can call self move to head node. And here we will also have, self move to head node. And then else if the length, if length key self key to node is equal to self capacity, that means it is full now, then we will remove the last node in list and add new one to head. Oh, then we can do it like we can separate these two functions, these two bunch of codes into two functions, like remove node so prev node will have self remove and then we'll add it to head. Add to head. So from node desktop. Okay. So add this node to head, so this node next will be the head's next, and we will reassign the head next to the current node. Okay. So self add head node. Then we can do remove. Wait, tell should we? Okay, it's fine. So we will do remove the last node, which is self next, self tell next, prev. And then we will add the new node to head. So the new node will be node list, whose value is value. Okay. We also need to add it to the dictionary. Key to node. And else, if the capacity is not full, then we should you will have added to the map and directly added to head without remove. Yeah. Okay. Kind of network problem. Oh, key to node somewhat. Okay. Forgot the self. Okay, I think it's maybe here, like, yeah, because it says no attribute next. Yeah, maybe it's because the new node. So when we remove the previous node, okay, yeah, this is none. We will remove the tail previous tail. Node of previous tail. So its previous node. Okay, maybe let's run like okay, check first. Okay, so we have two dummy nodes, and head next will be tail, and tail prev will be head. Forget yeah, if the get node, if key not in self, return -1. Remove self. Move to head will be remove the node and then add your head. So let's see how remove is written. Remove so x previous next will be equal to node and Yeah, I forgot to assign the previous. Okay. So the next node previous will be prev node. And others, should others do it the same thing? No next will be self had next. Self had next will be node and prev is node. Wait, no. Node prev will be yeah, node and we add somebody to the front, we should add its next to the head's next that node, and its previous would be node. And self had next will be node. And node prev will be self had. Smoke. And let's have node next will be self had next, and node prev will be self had. And yeah, node next prev will be node, and okay, so get to and should be removed, but it's not removed. forgot to remove. Yeah. Should also remove the key, the map. And add new value to the map. So this only adds new value and did not delete. Moving. Will be we need the key of node, so yeah, we should add key as well. We can default to 0. Yeah, and then we will have to remove the tail. We'll have removing. Previous key. Oh, prev this node. So we'll have removing key, and we'll have removing. Okay. Okay.